Um, yeah, so we just started our recording. Uh, can you put some reaction if you hear me, if you can see my screen? Um, I'm not sure if I can see any reactions. Uh, you can try to put something in chat. Just say hi. Oh, yeah, thank you. Thank you. I wasn't sure if the chat was working. Now it's working. Okay, so I guess we'll just wait for maybe one more minute. Yeah, thank you. Thank you. Okay, actually, why to wait? Let's just start because we have a lot of to cover today. Um, Again, thanks everyone for joining. Today we have a webinar about AI first coding, a practical guide to the future of software development. Um, a few notes for today's meeting. So first of all, questions are encouraged. You have a Q&A section in Zoom. So if you have any questions, put them there, and I have special slides to answer these questions. The next thing is to remember that the field is new and actively developing, and the things that I may be talking about today might be obsolete by tomorrow. So I hope we'll stay on the edge of today's technology and see what the future will bring to us. Okay, so um, first of all, let's uh, let me get to know you better. How familiar are you with AI coding tools? Just put in a chat the largest number that applies to you. I just want to understand how technically skilled is my audience today. So maybe you already know everything and I have nothing to tell you about. Okay, thank you for sharing. Using ChatGPT, great. Anyone else? Okay, ChatGPT, Perplexity, Claude, great, great. Okay, if you have anything more to add, just add it to chat and we'll start with the lecture. So, what we will be talking about today is first of all, we need to start with a brief history of vibe coding, just because this is where it started. Then we'll give a taste of what is possible with modern AI first coding now. Then we'll go deeper into theory. I'll talk about context in LLMs and then how to work with this context efficiently and give you some practice tips to apply in your projects, in your products, or in just your daily life. So the term of vibe coding is actually super modern because it appeared by the tweet from Andrej Karpathy, who is one of the almost godfathers of modern large language models. The term appeared just on 3rd of February this year, and still it, I guess, covered all the world now. And if I'm not mistaken, it's even became a word of the year from some dictionary. Um, in a nutshell, what usually people think about vibe coding is just to ask model to fix all bugs, to make no mistakes, and to push the button accept all until it finally breaks. Um, kind of vibe coding kind of resembles a casino. So you spend money on tokens, you push generate, you call yourself a prompt engineer, and you hope that thing will work, but it's not usually the case. And the problem here is quite simple and quite common. It is that using vibe coding approach, you can build a simple working product super fast, like in 10 minutes or even less than 10 minutes. But then you want to make some changes, and with each change, your large model seems to work worse and worse. Your coding agent become dumber and dumber, and finally you just gave up because everything broke and you don't know what to do. So the solution is simple, and we need to work with this solution. We first need to remember that sadly, large language models won't do all the work for us. On the other hand, it may be sadly. On the other hand, is that we will still have a job in the future. So, what's the solution overall? Let's think about goals, implementation, and plans as a human, but leverage large language models to implement these things. And let's rethink our approach of what a large language model is for us. It is not a slave who just do whatever you ask it to do. Instead, you need to think about it as a partner, because you need to help it to do better job, and that's on you. And more about it later. So what do we have so far is that vibe coding is unpredictable. It usually makes you want to break a laptop and run into the woods, and there is a much better approach. So as I promised, I want to show what the current state of the art in AI first coding is nowadays. So think to yourself, what do you think is the hardest task and project that can be solved by a large language model now without human intervention? And I have 3 examples here. Let's go through each of them. So first one is example by Anthropic, the company behind Claude Code, that said that they were able to merge 22K lines of code into their repository with reinforcement learning code base, which is a huge amount of code, and it was heavily written by Claude. We still need to think about it with a little skepticism, because they are promoting their product, but I'm not thinking they are lying a lot. The next project is, I guess, my favorite one, is that we usually think of AI first coding is applicable only for green-based code base, which means that there is no code, and you just create something from scratch from an empty folder. But instead, there are some approaches to implement and to fix issues and implement some code logic into already built, already designed legacy code bases, which might be huge. So this second example is a merge request made by mostly coding agent, which was made for 300,000 lines of Rust code base, which I think is quite impressive. And the last but not the least is more of a fun approach of what's the limits of large language models now. And it is a project which is a programming language in JZ slang written along with a compiler, which is usually not the thing that you think is possible to do with modern AI. Let's talk more. Yeah. So, disclaimer about these products. So, these results might be cherry-picked. So, yeah, think about it. The second thing is, of course, all of this is done not without special preparation. And a lot of work has been done to make this work. But still, all of these use cases are still impressive. Even if you made it work, it saves you a significant amount of time. And this is for you to have an estimate of what is possible with LLMs right now. Now, let's go deep into the last example I gave you. It is Cursed programming language. It was written by this fun coding agent called Ralph Wiggum. What do you need to know about it? It is that it is based on Claude Code, and it's actually a Bash script running in a while true loop. So it basically runs forever, calling a code agent prompted to write a compiler. Seems fun and seems engaging, but actually under the hood, it spent $3,000 on tokens, $3,000 on tokens. It worked for 3 months. It had to be restarted twice, and it was given a smart, actually very smart rule book to follow. So yeah, there is a lot of you can do with modern coding agents using AI first approach, but there are still a lot of techniques you need to apply, and it might cost you a lot. So key takeaways here is that the limits of what is possible might be much bigger than you may heard of, but it takes some tweaks and it might be expensive. Okay, I'll stop here for a quick session of questions. You can write down any if you have one. Okay, seems there are no questions so far. Okay, you can still write them down, and I'll ask them in a second Q&A section. Now, what I want to do is to give you a quick introduction to large language model context, a little bit of theory, just because this is the key of understanding its limitations and what we can do to overcome it. So, if you know, when we use large language models to predict some text, there is an intermediate step that translate our input text to a series of numbers, which is called tokens, send these numbers to large language models, which produces another set of numbers, and then it is translated back to get an output text. So LLM is not working with letters, with numbers. Instead, it's working with tokens. This is a primary unit of working with this kind of models. And for a model to predict something, we need to add system prompt to it, which describes how to talk to a user, how to behave, what to do, and what not to do. In our example here, we have 200 tokens for system prompt, 50 tokens for user message, and 80 tokens for LLM message. And I want to show you how model remembers the dialogue uh, which is um, which is happening. So large language model doesn't have a memory. It only remembers what's coming into it. That's why every time we want to make a conversation, we not only need to put our current message and send it to the model, but instead we need to concat it with the all previous history and put it all together and send to the model once again. Therefore, an interesting effect occurs that seems like you send in just a short message, but with this short message, a huge load of tokens from history came also. Um, so this is just a toy example. For example, if we are working with large language model in one of the modern IDE tools, we have a lot more to add. So we have system instructions, which came from a model, which we have rules, which came from the IDE we are working with. Every IDE have its own tools with descriptions that it is using to understand which tool to call and how to call it. And we also have a lot of connected MCP servers if you want to uh, take better from a world of today models. So every time you send a message, this huge part goes to a large language model. And for Claude, a rough estimate of all these instructions, just without any modifications, is about 3,000 tokens, which is quite a lot. For the context, these are the size which the context size of modern LLMs. What is context size? Context size is the maximum number of tokens that large language model can take as an input and produce some output based on this. So whenever we are sending something more than this amount of tokens, the first tokens that we are sending are just cut out. If we compare these numbers with the numbers from a previous section, you may just remember that this is like 3K tokens. It may seem like this context size window is huge, so why to bother? But actually, let's take a quick look into example I prepared. So for this, I used Cursor 2.0. I used GPT 5.1 thinking, and I used empty repo, and just to make sure that the experiment is valid. So if I just send a single message, hey, to my coding agent in Cursor, it already produces 15.3K of tokens. You may wonder why this is happening. And the answer is that not only agent wants to send like system message, system prompt, system tools to the model, but also Cursor as an IDE for developer, which wants to make a developer's life easier, sends additional information. So for example, in this case, not only my message is sent, but some preferences of mine are also sent. Some memories of how I prefer to work is also sent. So there is a lot of things that goes into this token, into this context. That's why it may run out very fast. So to continue this experiment, I created a new chat, and I wanted to create just a simple game, simple client for the game called Atari Go. It doesn't have any artificial intelligence underneath. It only have interface and ability to play with two players from one computer. My prompt was 200 tokens, quite small. But when I ran this prompt, the final context used by the model was 27.2K. And it's getting even bigger when I'm sending the second message, and the context used already, the context used almost became twice as large compared to the previous iteration. And the output is just 2.3 hundred lines of code, which is not big, which is just like a very simple app. So as you may remember what I told you about that, whenever we hit the context window size in a model, the model forgets whatever doesn't fit into this context window. And the other thing is that model is only smart enough when it knows with what it is working right now. So if there is something outside of this context window, then model is super stupid about it. It doesn't know anything. Therefore, maintaining all our data in this context window size is super important, and I guess the key thing about working with LLMs right now. Yeah, so the main limitation of large language models is the size of a context window. Usually, and actually not usually, always, large language models operates good while data is within the context. And most widely used coding model like Sonnet 4.5 have 200K tokens window size, which is just 13,000 lines of code, which is not so good. So, any questions here? Or we can continue. Okay, so can I create own model using NVIDIA processor chip running in my PC, and we can train for my own small task? Yes, you can do this. The question is, what quality do you want to achieve of this model? Which NVIDIA processor do you have? Because, for example, if you have a A100 processor, then it might be enough. But actually, yeah, you can train a small large language model on your PC. There are some examples on the internet that allows you to do it. But overall, if you want to achieve great quality, if you want to have a great coding agent, then you might need to build your own data center of computational power. Okay, let's move on. So, as I stated, there is a problem. The problem is that we want to keep our relevant data in the context, and we want to do it efficiently. So how do we do it? First of all, there is super simple approach. Just do nothing. Okay, so it might work for your case. You don't need to intervene. You just want to get your simple app, and it happened to work. So why to bother? No need. So you can just do like this. But there is level 1 simplest but Pro Max. You can create a new dialog for new task, which will reduce the context window size used. It will make your LLM much smarter, and it will take less of your money. The second thing is to disable and remove unused MCP tools if you have any. And you may also ask IDE to exclude some irrelevant files from scanning. Therefore, they won't end up in the context that your coding agent is using. The second approach, the second level, is almost the same. But when you achieve 40% of your context usage, you might want to ask your agent to compact and put everything it just did into an MD file and save it to your disk. Why this 40%? This is some magic number of large language models, and it is proven that if you occupy about 40 or 50% of your context window, the model is much more capable than if you occupy all of the context window. I see the question, is it load factor? It is not load factor, is a percentage of context using. So if your context is 200 Ks and you're already using 100 Ks of messages, data, system prompts that is sent to the model, then it's time to compact it, put it into an MD file, and load with the next agent. Yeah, so doing this and creating a new dialog and creating a new agent with this with the current progress kind of file, you'll save you a lot of money, and your model will produce better results just because of this simple magic number. The next level is kind of a more proactive one. You want not just to ask your model to do things. Instead, you need to think about what do you do in your daily life. Like, okay, so I am, as a programmer, do this code refactoring task. I do this, for example, unit testing tasks, and you want to create a sub agents that performs these tasks for you. And what's the reason behind this is that if you're calling these tasks in your main window, then subfiles, subfolders are also going into your main context. Instead, while creating a swarm of agents, you keep contexts separated, context of main dialog separated from the context of subtask, which will save you a lot of context and tokens. And starting from this approach, we are moving towards more agent-oriented programming instead of just one single LLM-oriented programming. The final thing here is not just to create your agents, but to rethink the approach you're taking when working with LLM. So what I want to demonstrate here is that what do you know about large language models now? That they're great at writing code, but they usually tend to imagine a lot for you. So, for example, if you ask your model to create a simple Atari Go game, it may create it in Python, it may create it in JavaScript, or whatever it decided to create. So, yeah, large language models tend to imagine things. And we don't want this in real life code repositories because there are strict standards we need to follow. There are architecture of our code we need to follow. So we don't want any strained architecture decisions within our code. So given this, we know that large language models are bad at creating a plan based on vague input. So you want to create a plan that will lead to a good code, and bad plan leads to a bad code. The idea spreads further. So if an LLM have a bad understanding of the project it's working on, then it tends to create a bad plans. So what we want to think about here is that we need to change where we put our effort as developers. So instead of focusing on the lines of code that model produced, we need to think more and reflect more on the plans that model gave you and on the research and the data the model is and the research which model is able to access. To do so, so I have a picture right here. So what we want is we want to like break the work we are doing with LLM in 3 separate tasks. So first we want to ask a model, an agent, to do a research. Then based on the research, we want it to do the planning. And only after planning and on the plan that it produced, we want to make it to implement what has already been planned. The key thing here is we not just ask LLM to do this. Instead, we need to carefully read through, check everything that model produced. So when we ask the model to do research and create a research overview of our project and architectures that our project have, then we need to check if it is a reality or it is not. The same goes for planning. So if we ask a model to create a Go game, we look at the plan that it produced and check, okay, so if it is written, if it is going to write in Python or if it is going to write in JavaScript. And we need to check and to change things here. So on a steps of research and planning. Now, the idea here is simple. Our main goal as developers is to provide high quality specification and plans. And we can let the LLM to produce a specification and plans, but we need to pay our full attention to the result of the steps. So as I mentioned that we want to ask an LLM to research and to create plans and to implement plans. There are great examples of prompts to do so given in the links. You may check them out later. So key takeaways here is that we want to put all our effort into context management, and we also want to put all of our effort onto plans and specifications, not the output of the models that it produced. And as long as your goals and plan and the specifications are great and clear, then the resulting output is also will be great. Okay, any questions here? Okay. Let's move on. So, Final chapter for today is some practice tips that I advise everyone to use in their work with IDEs. So first of all is to get used to plan mode. A couple of months ago, planning of the work that LLM will be doing was just a theoretical concept that only pioneers of AI first coding were adopting. Now this plan mode is almost in every LLM powered IDE, and it works from the box. And I encourage everyone to get used to it. Because as I mentioned, a great plan leads to a great code, and bad plan leads to a bad code. The second tip is to monitor your context usage, and don't forget to create new dialogues whenever you feel that your model start to struggle, when your agents start to create nonsense. Your first thought must be to go and check the context used and to create a new chat, and to create a new chat. The third tip is to run multiple instances of the model to select the best result. So we usually work with the approach that we have only one model and only one output. But for example, in Cursor 2.0, they implemented a feature that you can run a number of simultaneous models, if I'm not mistaken, up to 8 models on the same task. So now you, instead of just waiting for one output, you can wait for 8 outputs of 8 different models, and choose the best that worked for you, which make your planning and code execution is much simpler. Of course, it used much more tokens, but it might be the price you want to pay for getting better results. Finally, I'm not sure if this feature is already implemented in Cursor 2.0. So I mentioned here that it works better with Claude Code. And the feature is to create sub-agents that I mentioned in previous section. Sub-agents are great whenever you have a repeating work you implement, a repeating work you do with every repository or with every task you have. For example, in my own experience, I have an agent that makes a code review. I also used an agent that fix my mistakes and fix my grammar, and this is just super great to speed up your work. Now, we are almost at the end, and I have 2 more things to share with you. So, first thing is that starting with this, or next week, I'm not sure, we are having our 2-hour workshops about AI first coding, which are led by industry expert. There are 4 workshops. You can attend each of them separately, or you can attend all of them in a bundle. And more information is on the QR code. And this is workshops to get a real skills, hands-on skills with agentic coding. Not just theory, instead a lot of practice. The next thing is, if you're more interested in theoretical and more in-depth approach to models, to coding agents, you may also want to check out our new course on LLM agents. There is a lot of theory what lies underneath agents, why they are working as this, not as that, how to build your own agent, and of course, there is theory with practice. Yeah, so we are approaching the end of our presentations. If you have any more question, you can write them down now. And thank you for coming. Thank you for listening. Okay. Oh, yeah. So, um, hi. Talking about tokens, the Syntune will be available for us and LLMs near soon. Um, I'm not sure. I'm not familiar with this library. Um, I'll check it out later. Okay, so I guess there are no more questions. Thank you again for joining today. It was a pleasure to present to you, and have a nice day. Bye.